All right, in this video, I want to give you a little bit of a crash course here in R and how to use R to calculate different terms equated to the binomial distribution. And so what I want to do is let's go back and let's think about our example that we just talked about having the red and yellow marbles in the same bag. So if you remember, we had 8 marbles, 3 were yellow, 5 were red, and then a success was selecting a yellow marble, and we chose 4 marbles with replacement. So that was the basic setup there. So what I want to do is I want to show you how to use R to get the values that I was talking about in that video. And if we go to the R commands, this is the top of the second page. So this is going to be chapter 5 stuff. There's not a lot of stuff in chapter 4 that's in R, but chapter 5 has some nice functions that are built in. And there's going to be really 2 basic commands that I think will be useful when we do these binomial distribution problems. And that's the D binomial and P binomial functions. And I want to point out just in general, whenever you're using R, if you need any sort of a background, if you need to read any documentation about a function, and of course everybody does, I do too, regularly. So if you need to know anything about a function, what you can do is you can type help, and then whatever the thing is that you want to know about, so say you wanted to talk about standard deviation, and then it'll come up with a help document on the standard deviation and all the different arguments and details and so on. So anyway, so that help thing is there. Also, there's a lot of documentation on the web. And if you want to open up a website, you could do help.start, and that'll open up a website, or at least it should open up a website, so that you can again read that same documentation, but it's really the documentation that's already there. So that help function is built into R. That's very useful to know. So let's talk about the D binomial function and the P binomial function, which would be the useful ones for us. So these have the same, they're in the same R documentation. And I have it nicely worded, I think, on the R commands Google document. D binomial is going to give you the probability of X successes and T trials. So notice here that I'm using T to denote the trials instead of N. And the reason for that is just so that R doesn't have a fit. R likes to use N for the number of samples. So I had to change the N to a T, but T is the number of trials. So in our marble example, where we pick 4 marbles, our T was 4. And then X is going to be 0 through 4, so the number of successes. And P is the probability of any one success, where the probabilities are the same each time. So, so let's jump over to R. And what we could do is if I were to find the probability of getting 0 marbles out of 4 trials, where the probability of getting a yellow marble was 3/8, that's the number 0.1526 that we talked about. Okay, so that's one way to do this. And then you can do D binomial. You can do this for all of them. 1, 4, 3, 1, 4, 3/8. D binomial you can do for 2, 4, 3/8, and so on. And you can do this for the others. It's a little bit annoying to do it for all of them, but luckily there's a nice shortcut. One thing that you can do here, and this is apparent in the documentation, and this is where opening the documentation will really help. So one thing that you can do here is notice that X, your argument that goes in here, can be a vector. In other words, it can be a list. So if I wanted to, rather than typing all of these out by hand, we could put in our list X. So there's a few ways to do this. But if you let X be 0 through 4, you can do D binomial X for 3/8. And then what that'll do is it'll output a vector with each of these numbers in it. So the 0.1526, 0.3662, and so on. Okay, and that's a nice way to do that just very succinctly. There's a slightly quicker way to do it as well. If you want to store a list, so notice that our list X is just the number 0 through 4. Another way to write that list, if you have a range of integers, is just 0:4. That gives you the numbers, including both endpoints, 0, 1, 2, 3, and 4. So you could do, without having to store anything, you could do 0 through 4 and 3/8. And notice also that you could do, if you only wanted to know what happens at 0, 1, and 4, for whatever reason, you could do that as well. And then that'll give you just the value at 0 successes, 1 success, and 4 successes. So to give you this number, so 0 successes, 1 success, and 4 successes. Okay, and so let's do this one more time. So D binomial, I want to know the probability for each of these if we have 4 trials, and the probability of a success was 3/8. So there's our list of vectors. And one thing that you can do is let's store these. I'm going to call this P. Let's store these as a list. So P is going to be our list. And the reason why I would want to do that is just to show you a few things. One is that if you add up all the values on the list, so if you sum up all the values, you should get 1. Or sufficiently, it's possible that you don't get exactly 1. Maybe you're off a little bit just by rounding, but in this case, it's fine. There's a few other things that you can do as well. If you wanted to calculate the expected value, so what that would be for expected value would be 0 times 0.152 plus 1 times this value plus 2 times this value, and so on. And I think it might not like those spaces. Plus 3 times this value. So that would be your expected value. And again, luckily, there's a nicer way to do that as well. Now, it turns out that we have 1.5 as our expected value. And that should make total sense if we think about the fact that there's 3 yellow marbles and 5 red marbles, and we do it 4 times. So that means 3/8 of 4 is roughly how many, and 3/8 of 4 is 1.5. That's roughly how many yellow marbles we would expect to pick if we were to do this for 4 trials. Luckily, there's a quicker way though. So remember that X is our list of the outputs of our random variable. P was our list of probabilities. And it turns out that you can multiply these 2 lists. And if you multiply the 2 lists, what's going to happen is you're going to get the products here, 0 times this number plus 1 times 0.366 plus 2 times 0.3295, and so on. And so let me show you what that looks like. That's not exactly what we're looking for. But what we're looking for is actually the sum of the values on that list. And so this is a nice way to find expected values there. Okay, so the sum of the values on the list you can come up with is 1.5. Knowing these shortcuts, I think, is going to be super helpful for doing these problems, especially on exams where you're timed and on quizzes too. So again, just as an overview, D binomial of 2, 4, 3/8. What that does is that tells you what's the probability of having exactly 2 successes out of 4 trials, given that the probability of a success is 3/8. And that was the 0.3295898 number. One other function that I think is useful, okay, so one other function that I think is useful is the cumulative probability. So our probabilities P is just the probability of exactly 0 successes, exactly 1 success, exactly 2 successes, and so on. But one other thing that we could do is, what if we wanted to calculate what's the probability of having at most 2 successes? So what's the probability of selecting 2 or fewer yellow marbles? Well, you could add those numbers up. And indeed, let's do that. Okay, so we're going to take these numbers, and since there's only a few, maybe it's easier just to actually do this by hand. So if you add those numbers up, the probability of getting 2 or fewer yellow marbles is 0.8484. But there's also a built-in function for that, and it's called P binomial. And what this does Let me go back to the documentation here. P binomial, good. So what this does is it'll give you that cumulative probability. We want to know what's the probability of getting at most 2 successes, and it'll spit out that number automatically. This is really useful when the number of trials is large. So just as an example, let's say what we're going to do is say we have a 100 question. So let's say we have a 100 question true-false exam, and we want to know the probability of getting at least half the questions right. What we would do is we want to know the probability of getting at least 50. I'm sorry, we want to know the probability of getting at most half the questions right. So we want to know the probability of getting at most 50 out of 100 trials, where the probability of a success is 0.5. And so it turns out that there's roughly a 54% chance that you would get 50 or fewer questions correct. Okay, so that's what that says. I'll do a few worksheets where I have these problems written out a little bit nicer, but these p binomial and d binomial functions can be really useful, especially when the number of trials is large.